The purpose of this short video is to explain the main features of the revised trials interface for the protection range estimator device, which I'll call a PRE device for short. When the PRE software starts, there is a choice between the development interface, which is the familiar complicated one that's been shown incidentally in other videos, and then there's the trials interface or the hardware demo interface. So let's choose that one and click Proceed. The next thing that appears is a control form so that we can demonstrate the trials interface. This form is not used in trials, it's just used for boardroom explanations and videos like this one. So if we click the Show Hardware Interface button, the trials interface finally appears. The trials interface has three versions selected by this radio group at the bottom here. The first one is based on range between the ECM system and the PRE device. The second one is based solely on RF power received by the PRE device. And the third one draws the ECM protection bubble on a live webcam video. And we'll start by talking about the interface based on range, which is shown here. On the left side, the main features are three panel lights indicating the safety at the PRE device's current location: green for safe, yellow for warning, and red for danger. To the right of the panel lights is a thing called a level bar, which represents the range between the ECM system and the PRE device, measured in meters. The level bar is divided into green, yellow, and red partitions, which have the same meaning as the panel lights. The highlighted part of the level bar indicates the current PRE device range from the ECM system, which is also indicated by the red needle. The numeric position of the needle is indicated by the red label beside it. The green and red regions are separated by the yellow warning region, which is defined by its inner boundary, meaning close to the jammer, and outer boundary, meaning farther from the jammer. And the values of the inner and outer boundaries of the warning zone are shown by the text labels floating near their edges. On the extreme right is another level bar. This one's colored gray. This is a control that adjusts the definition of the warning zone so that the ground truth protection range lies within the warning zone with a given probability. For example, 95% is what it's set to now. The meaning of the warning zone is critical to understanding what the PRE device is doing, and the best way to understand this is by pictures. So here are some to explain what the warning region is and what it means. Remember that all calculations performed by the PRE device are statistical and account for the fact that there is uncertainty about virtually every aspect of the attack scenario, where the IED is, where the trigger man is, and what the general geometry of the attack is. All of these things are taken into account by the PRE device, and therefore a statistical result is produced. So here's a picture of the output of the PRE device. It defines the green for safe, yellow for warning, and red for danger regions around the jammer. Now, since we don't know all the attributes of the attack scenario, such as how far away the trigger man is, or how powerful his transmitter is, or what the gain of the transmit or receive antennas is, or what scatterers there are in the environment, the meaning of the warning zone produced by the PRE device is this: it contains the ground truth ECM protection range, the protection bubble size, with a certain probability. Let's flesh this out a bit more. Suppose we do an experiment where we determine the ECM protection range for half a dozen different attack scenarios by moving a mock IED receiver down a test range farther and farther from the ECM system, and at each range step we check whether the IED receiver can be triggered. So the results might look like this. And if we did several different attack scenarios, the results might look like this. We repeat the experiment half a dozen times. The yellow region in each case, the little narrow yellow region, represents the region over which the ECM protection is observed to be intermittent. This means that the ECM is intermittently successful in preventing the trigger signal from getting through. So in simple terms, it demarks the outer limit of the ECM protection range, the bubble size. Because the protection range depends on the attack scenario and a number of other variables, each attack scenario potentially produces a different protection range, a different bubble size. However, and this is the key point, they all lie within the warning zone calculated by the PRE device. So let's go back to the trials interface. control on the right side, that gray level bar, is used to set the % probability that the ground truth ECM protection range, in other words, the protection bubble's boundary, lies within the PRE device's indicated warning zone. So let's adjust it. It's at 95%. Here it is at 90%, 80%, 70%, 60%, even 50%. Notice that as the probability is reduced, the warning zone becomes narrower. Now this makes sense, but you have to look at another picture to make sense out of it. In the real world, the attack scenario variation splashes the ground truth protection range across a range of values. So when we calculate it using all the possible attack scenarios, the protection range is expressed as something called a probability density function, also called a PDF. A PDF is a graph of the likelihood that the ground truth protection range is at a particular range. And the probability that the ground truth protection range lies between two range values is just the area under the PDF curve. As the user makes the probability smaller, the range interval in the probability density function becomes smaller. An operational PRE device probably would use a preset value here for the inclusion threshold, or the value could be automatically set by an expert system application of some kind. This control on this form is provided only for illustration and explanation purposes, and it's to provide some flexibility in field trials. So let's go back to the trials control form for a second and change the range between the sensor and the ECM system. When we do that, the active part of the level bar goes up, and as the sensor moves farther away, or the PRE device moves farther away from the ECM system, we move from the green to the yellow region, indicating warning condition, meaning that the protection bubble may be here or nearby. And if we move farther out, farther away from the jammer, it turns from yellow to red. I'm running out of room on this form here, but you can see that at a farther range, 149 meters, we're in the danger region in this example case. Now let's have a look at the power-based version of the form. Let's move the operator back to a safe region, just for fun. Again, this is not the interface that would necessarily be used in an actual device. This is an interface for a field trials demonstration, so it has extra controls on it so we can see things and investigate their usefulness to figure out what would go on into an actual fieldable device. The display looks similar to the range-based display, except the level bar now has a different meaning. The level bar now represents received power from the jammer. I notice that the green and red regions are reversed from what they were before. Like previously, the green region was at the bottom of the level bar. Here, well, let's go back to the range one. See, the green is at the bottom and the red is at the top. But in the power-based one, the red is at the bottom and the green is at the top. Now this is because the top of the bar represents high power, which means high ECM power. So if we have this much power, we are safe. Below this is the yellow warning region, and below that, at a lower power still, is the red danger region. The meaning of the warning region is the same as already described. And notice that again, that as the probability of inclusion control is changed, the width of the yellow warning region changes again, and in the manner already described and for exactly the same reasons. Let's just change the range between the PRE device and the ECM system, and we can see what's happening. As we go farther out, you get less and less power, and you move from the green safe region through the warning region and into the danger region. So we'll just move back. See this happening again. Again, this is all based on a simple power measurement. Now this version of the interface is probably the most useful. It relates a simple power measurement to the true ECM protection based on the ECM antenna height, the ECM transmitter power, the ECM antenna gain, and all the likely statistical variation of the threat parameters and the attack scenario parameters. All this assuming a flat level ground. If the ground is not flat and level, the received power will be affected and the device will indicate when the power level falls into the warning region, regardless of the distance between the jammer and the sensor. This means that a remotely operated handheld device is, for the first time, able to warn an operator when the environment or something else has compromised his or her Counter-IED ECM protection, whether you're inside the bubble or outside the bubble. And once the PRE device has given an operator a negative indication, it is also able to advise whether the action he or she has taken has remedied the problem. For example, by falling back closer to the jammer, or by stepping away from a building or a vehicle, or by removing an obstruction between himself or herself and the jammer, or by ascending or descending a hill. A significant enhancement to this functionality would be to provide a visualization of the protection range, like using, for example, a webcam. Now, this has been achieved for flat level ground, but it's outside the scope of this short presentation. And this concludes the explanation of the current version of the PRE device's trials interface.